This is continuing with a lecture on the chain rule. And these are review problems. All right. So the chain rule is a rule for finding the derivative of a composition of functions. Right. So it's not multiplying functions, it's a composition. And for A, we have y equals parentheses x squared plus 1 to the third power. What I mean by a composition is that you could write y as u to the third power. I informally call that the outside function. And then inside, there's a function u, and that's x squared plus 1. Okay, u equals x squared plus 1. Now, what I do is I take each of these by themselves. So what I just did is I highlighted x squared plus 1, what I'm calling the inside function, but I use a dark highlight so that I can, in a way, just try to ignore it, like almost, not even see it for a moment. So I have y equals whatever's inside to the third power. In other words, y equals u to the third power. And I take the derivative of that, but I don't think about what the inside part is. I only think about this u to the third power, and I use the power rule, and I get 3 whatever's inside to the second power. That is the derivative of u cubed. The derivative of u cubed is 3u squared. What goes inside? The same thing that went into our original function, x squared plus 1. So what I just did is I took the derivative of u to the third power, which is 3u squared. Now I multiply by the derivative of this other function, u equals x squared plus 1, and that derivative is 2x. So this part here is the derivative of x squared plus 1. And then, there's a little bit of, well, how should I simplify it? Should I multiply everything out? Or I'm going to multiply 3 times 2x and get 6x. And I'll have 6x squared plus 1 squared. So what's going on is I have 2 functions. I'm calling them the inside and outside function. And I took the derivative. Okay, maybe I'll see what I'm going to do is make it more complicated. That was nice and short. But I took the derivative of the outside. I took the derivative of the outside, y, and that's 3u squared. That was this part, 3 whatever inside squared. That's the 3u squared. I took the derivative of u with respect to x, and that's 2x. That's this other part over here. Okay, by the way, when I have 3u squared, I put u as x squared plus 1. And then I just multiply them together. So in other words, the derivative of y with respect to x is equal to the derivative of y with respect to u times derivative of u with respect to x. Now, all that stuff I'm writing here, I do think makes it look more complicated. And I a big part of me thinks, why am I writing all this stuff on the right-hand side? Why am I doing that? It's just made something seem even more difficult. So all that stuff that I just wrote, you might just ignore that. Okay, because it's supposed to help us, but I think sometimes when I write more, it doesn't help, it makes it worse. So, okay. All right, let's just try the next one. All right, so here we have y equals sine u, and u equals 3x. Okay, so there's a composition of functions. What I'm doing is I take the derivative of sine u, which I hope you remember is cosine. And then what goes back in there is u, which is 3x. Then I multiply, okay, so I have this inside part is 3x. I sort of ignore it. take the derivative sine, and I get cosine. I still put 3x inside. Then I multiply by the derivative of 3x, which is 3. So after I've sort of ignored the inside, I need to then think, oh, what's the inside again? And I take that derivative. So y prime equals 3 cosine 3x. That's that answer for that. And let me highlight the answers. Okay, let's try this other one. Here we have something that's a little different, and it's important to pay attention how it's different. This is y equals, I'll write parentheses cosine x all raised to the 4th power. So see, y is u to the 4th, and u equals cosine x. So I take the derivative of u to the 4th, which is 4, whatever happens to be inside, to the 3rd power. Well, what's inside is cosine x. So I leave that there. Then I multiply by the derivative of what's inside. I multiply by the derivative of cosine x, and that's negative sine x. And I'm just going to, rewrite that to make it look a little better. Okay, so only on part A did I write all that stuff out. Well, I wrote a little bit here and there, but you don't have to write this y equals sine, like very last one, y equals u to the 4th, u equals cosine x. But that's what's going on if you could write it. Okay, are there any questions on how to do any of these problems? I can finish the video if you want to do a question on video also. Okay, so hopefully I didn't make any really bad, terrible mistakes, but so we can use this video. So let's just finish up.